Can we start the class now? Okay, let's start the class. I guess the people are joining, that's why I was waiting for 1 minute or 1.5 minute. Okay, I'll wait for another 30 seconds. Hi guys, welcome to NEET World Institute and NEET World YouTube channel. Yes, in today's class we are going to concentrate on this thermal properties of matter and the thermodynamic questions, okay, and which we have discussed about the topics of these two topics in last class now, and today's session is like purely questionnaires, okay. So in previous classes also, like last 2-3 classes also, we were seeing questions of these two lessons, right now. Yes, and we will continue with the questionnaire session. Yes, let us start with the first question. The value of the coefficient of volume expansion of a glycerin is 5 into 10 power minus 4 per Kelvin inverse, per Kelvin. Like the fractional change in the density of a glycerin for a rise of 40 degree Celsius in its temperature is, okay, and I am like taking the like JEE mains question and NEET question, EAPCET questions, and then some other questions also, like I am mixed together everything so that it will be easy to analyze, no, like only if I talk about only the EAPCET questionnaires, na, like the difficulties you won't feel, like I will added difficult, more difficult and moderate questions also, okay. And this is the first question of this class, and you have a solid 1 minute time for this question, and let me give you the given things first, and you can take this 1 minute first, okay. So volume expansion, that is alpha is nothing but linear, beta is nothing but the aerial, and gamma is nothing but the volume expansion, which is nothing but 5 into 10 power minus 4 Kelvin per meter, Kelvin power minus 1. The fractional change of density they are asking. So delta V by V is equals to gamma delta T is the condition we know, right now, the condition we know. When we talk about the density, relation between volume and density, what is the relation? Density is equals to mass by volume. When we talk about the density and volume, density is inversely proportional to volume, right? So take this relation and take this relation and compare these two relations and give the answer for this question. Got it? And what about the temperature? Temperature they have given delta T is equals to 40 degrees Celsius. Okay, we have the temperature, we have gamma, and we need to find only the delta rho by rho, the fractional change of density. Okay, yeah, you have a solid 1 minute time. You can take your time and give answer for this question. Option 1, 2, 3, 4, which is the correct answer. Yes, so today we will discuss some set of questions, okay, some set of questions. so that it will be easy to analyze, like the different kind of questions also we will see. Like yesterday we have seen some questions. Yes, whatever questions we have discussed in last 3-4 classes, no, that's of EAPCET, NEET, JEE mains and some other entrance exams questions also have been included in this, so that it will be easy, no, so that it will be easy to analyze that questions, right? I guess the camera is clear, right? Okay. Yes, I guess the time is up. We'll see the steps, okay? Yes. So the volume expansion, so alpha, beta and gamma, gamma, it's the thing, okay? Please change it here, it's a gamma. So gamma is equals to, okay? Gamma is equals to 500 10 power minus 4 Kelvin power minus 1, and temperature, right, temperature. Now why we have taken minus here? Listen carefully here, listen carefully. So when we talk about density is inversely proportional to volume, or volume is inversely proportional to density, the two things we can take it. And when I take this, volume is directly proportional to density power minus 1. Can I write like this now? Okay, fine. Now the ratios, like the fractional change, if I talk, can I write delta V by V is equals to, for example, like I will take the equals to, what is the power? Minus 1. And what is this fractional change? Delta rho by rho. Got it? Now this is my equation 1, let me take. And what about the other equation? We know that delta V by V is equals to gamma delta T. Equate this both the things. Now delta rho by rho is equals to minus of gamma into delta T. What is the value of glycerin? That volume expansion is given. It is 5 into 10 power minus 4. This is minus, minus times I should take. And what is the temperature? It is 40. So 40, right? So 5 into 40, it is 200. So I will write here 200 into 10 power minus 4, 2 zeros and 2 zeros will go, and 0.02 is the minus 0.02. Minus 0.02, and the answer is, if you talk here, it is 0.02. Okay, option 4 is the answer for this question. Option 4 is the answer for this question. So whoever are watching, you can give answer in the comment section, so that we can cross verify the answers and we can check the answers. Okay, I guess this is clear, The next question we will see. Yeah, a piece of ice falls from a height edge so that it melts completely. First thing, first part of the question, ice is there, it is falling at a height of h, and it completely melt, it is melted, completely melt in the sense it becomes water, right? So initially the solid part is there, solid and a liquid. Only 1/4 of the heat produced is absorbed by the ice, and all energy of ice get converted into heat during its fall. What is the meaning? Only 1/4, 1/4 of the heat produced is absorbed by the ice, and all energy of ice get converted into heat during its fall. Okay, the value of H is, they are asking, okay, and latent heat of ice they have given, and G they have given. Okay, why they need to give ice? Since when we talk about a solid, it is converted into liquid, the state is getting changed. Here the state is getting changed. So which means I need to use two formulas. One formula is Q is equals to mc delta T. Other formula is Q is equals to ml. Okay, and time starts now. A solid 1 minute. Yes, last 10-15 seconds. Yeah, last 15 seconds. Okay, guys. So, and if you see here, latent heat of ice has been given 3.4 into 10 power 5 they have given, 10 power 5, okay, and value of G also they have given, and only 1/4 they are telling no, which is observed in the fall, which is nothing but what is the energy which is getting fall? Potential energy or kinetic energy? Like initially it has been stored, right? It was stored, which means potential energy mgh. How much? 1/4. 1/4 they have told, 1/4, and like converted into heat during its fall, which is nothing but m into L. So mgh is equals to ml on this 1/4. 1/4. Cancel. Cancel. And what is the thing they are asking? So the value of h, value of height, G is equals to, sorry, h is equals to L is 3.4 into 10 power 5 and into 4 divided by 10. Right? No, that's the thing now. Got it? So 34, 68 2 times, so 136 we will get. So how much? 13.6 and 0 will get cancelled, 10 power 4. 13.6 into 10 power 4, or else we can write this as options are given 136 kilometer and 68 kilometer, 34, yes, 136. I can write this as 136 into 10 power 3. So 136 kilometer is the option. Option 1 is the correct answer. Got it? Yes, the next question we'll see. So next question, a black body is at a temperature of 5760 Kelvin. T is equals to 5760 Kelvin. The energy of a radiation emitted by the body at wavelength lambda is equals to 250 nanometer is U1 at a wavelength 500 nanometer is U2. So this is U1 and 500 nanometer is U2, and that at 1000 nanometer is U3. Okay, 1000 nanometer is U3, fine. So Wayne's constant B they have given, B is equals to 2.88 into 10 power 6. Which of the following is correct? So U1 is equals to U2, U3 is equals to U1, U2 is greater than U1, U1 is greater than U2. So I need to find the relation. So first of all, what is the relation between the temperature and the wavelength? Right? I need to find what is the temperature and the wavelength. If we know the relation between temperature and the wavelength, if we know the relation between temperature and wavelength, so we can solve this question easily now. Okay, so we have a solid 1 minute time for this question. Okay, start guys. Okay, time up. Time up. Okay, so if we talk about Wayne's constant, like Wayne's displacement, what is the thing we have discussed? Lambda is inversely proportional to T. Lambda is inversely proportional to T, right? So what is the thing we can observe here? Lambda into T is some constant. So that constant, Wayne's constant we are talking, right? Now given that T 5760 Kelvin, lambda 1, lambda 2, lambda 3, lambda 1, lambda 2, lambda 3, okay. So which is the closest thing we can observe here? And I need to find the values first. So 5760 into, what is the first one? 250. 5760. What is the second one? 500. What is the next one? 5760, and this is 1000. If we see, U3 will be greater, U2 will be greater than U1, right now? That is the thing, no? U3 will be greater than U2 will be greater than U1. Got it? And if you see the options, U1 is equal to U2, like I can neglect it immediately. U3 is equal to U1, I can neglect it. U2 is greater than U1 or U1 is greater than U2. So I am coming from 3 to 1. I am not going from 1 to 3. Neglect it. Option 3 is the answer. Got it? The next question. The refrigerator works between 4 degrees Celsius and 30 degrees Celsius. 4 degree and 30 degree. So let me take T1 is equals to 4 degree Celsius, T2 is equals to 30 degree Celsius. It is required to remove 600 calories. 600 calories, which is nothing but heat Q of a heat every second in order to keep the temperature of a refrigerated space constant. The power required, what is the power? Power is equals to energy by time or work done by time, right? So this is the given things in the equation and your time starts now. Time up, time is up, time is up, time is up. Now, so first thing, what is the thing we need to do? Calories they have given, convert it into joules. So joules in the sense 4.2 multiply 4.2 times, so into 600 I'll get 2520 joules per second. Okay, what is the COP of refrigerator? Temperature, the low temperature minus divided by the ratios, the ratio of low temperature to the change in temperature, that's high temperature to low temperature. Na? So TL by TH minus TL. Got it? And when we talk about this thing also, I need to convert it into Kelvin. Kelvin. So 273 plus 4, 273 plus 30. So the low temperature is 277 divided by 270, how much? 273 plus 30 is 303 minus 303 minus how much? 277 na? 277 will gives how much? Will give how much? 277 divided by, and this is 23, 26 we will get na? 26 we will get 26. So what is the thing we will get here? Around 10 times, okay, 10 times, okay, 260 and 260 plus 26 to 286 we will get around, so 0.5 we can say now, like around 0.5 calculation, 10.5, okay. So they have taken 10.65, it's fine, but when you are doing calculation you need to be sharp right now, like to get the approximation value. So and it is P is equals to the calories, like a Q, okay, heat by COP. So what is the COP we got? 10.5, and what is the thing we got here? So 2520 divided by 10.5, that's it, you will get the power, you will get the power. So option, which is the correct option? 23.6 to 36.5, like option 1 and 2 are both are same, like, so we need to change this option, I will change that, okay, no need to worry about that. And 236.5, what is the correct answer for this question? Got it? The next question, yes, the molecules of a given mass of a gas have RMS velocity 200 meter per second at 27 degrees Celsius and 1 into 10 yeah, 10 Newton per meter square. Pressure. When the temperature and the pressure of a gas are respectively 127 degrees Celsius and 0.05 into 10 power, yeah, I'll give you that, no issues. Okay, how much they have given? 10 power 5, 10 power 5, the both things. 1 into 10 power 5, 1 into 10 power 5, okay. This is 0.05 into 10 power 5 and this is also 1 into 10 power 5, got it. So the RMS velocity of its molecule is, okay, you have a solid 1 minute time for this question. Last 30 seconds. Yes, the time is up, time up, time up. So VRMS is nothing but it is root over 3 RT by M, right. So when they are giving the temperature, temperature, how much the temperature they have given, okay, like one is 27 and one is 127, one is 21, and they are asking the velocities ratios. So V1 by V2 is equals to, V1 by V2 is equals to, what is the relation between temperature and the pressure? P is directly proportional to T, right, right. PV is equals to nRT, nRT, got it, na? And if you see here, T2 by T1 and it is P1 by P2, got it. What is T2? T2 we are considered 127 in the sense plus 273, so we will get 300 400, right now, root over 400 divided by 27, 273 plus 27 300 divided by into root over, and this is 1 into 10 power 5 divided by 0.05 into 10 power 5. I guess it's clear now. So 2 zeros and 2 zeros, 10 power 5 will get cancelled, root over 4 by 3 into root over, and this 2 zeros I can take it up, zeros, and this is 5 1 times and 20. So how much? 2 divided by root 3 and into root 20, I guess that's the correct, that's the correct thing. And yes, we can write this as 2 into root 20 divided by root 3, 2 into root 20 divided by root 3. Anything is given? Yes, velocity is given, V1 is given, V1 is given. I can rewrite this, so V1 is 200 meter per second, no, I can substitute the V1, so this is not V2, it's V2 by V1 into 200. So it is 400 root 20 by root 3, 400 root 20 by root 3. Got it? Got it now? And yes, up to this I have solved, and you can calculate it and get the answer for this. Okay, that's the end of the session. Okay guys, with this we'll wind up today's class, and I guess you hope to enjoy this class, right? Okay guys, thank you. We'll see you in the next class.